Hello and welcome to my Naming Binary Ionic Compound series. This is part 1. We're going to start with the simplest rules and then we're going to start adding more and more in each part until we've gone through all the rules and we're able to successfully name almost every binary ionic compound. So today we're going to start with the simplest rule. Let's get started. Here I have all of the rules for our naming binary ionic compounds. In the case of binary ionic compounds, we always name the cation first. In that case, we always name the positively charged ion first, and then we name the anion second. That's going to be the negatively charged. We also tend to write the ionic compounds positive or the cation first and the anion second. Now, in the case of today, we are going to only focus on some of the rules. We're only going to focus on the element name and this portion right here, which I'll explain in a second. In later videos, in the later parts of this series, we'll go over some of these rules I'm crossing out. But for right now, we're just going to focus on one rule, and then we'll add these in later as we get to more and more complicated binary ionic compounds. When we're naming these, we're going to name the cation first, and what we do is we're going to just do the element name. So if we have something like NaCl. Now we know Na is an element. We see that uppercase letter and then a lowercase letter. That tells us Na is an element. In this case, that element's name is sodium. For the cation, all we have to do is write the element name. In this case, sodium. Now here's where the second rule comes in. We have something that says root plus IDE. In this case, Cl is chlorine. Now, we only want the root of this word, which is the CHLOR. We're going to cross off this ending, and we're going to add IDE as the new ending. So that gives us, instead of chlorine, it gives us chlor, and then IDE, or chloride. The name of NaCl is sodium chloride. Now let's look at a few more. I have 3 more practice problems here. And now what I would suggest is that you try to pause this video and try to identify what these names are yourself, and then replay the video once you have some of these names and watch as I go through it and make sure that you can get the right answer for yourself. I'll go through all of these examples, and I have 3 more complicated examples on the next slide as well. Our first one is NaF. Now, you might remember from that previous slide, Na is sodium. So I can just write the element name because Na, or sodium, is our cation. Remember, we're not doing any of these rules yet. And then the F, we need to take that root plus IDE. Now F is fluorine. Now we're going to cross off that ending and add the IDE, and fluorine becomes fluoride. That ion is called the fluoride ion. So F minus, as an anion, is the fluoride ion. Our next one is KBr. Now again, we're going to, for our cation, which in this case is our K, which would be a K plus ion, we just need to do the element name. In this case, the element name for K is potassium. I just need to write potassium. Now in the case of Br, Br is over here, and Br is bromine. Now just like before, we take the root plus IDE, so bromine becomes bromide. The name of this one is potassium bromide. Next up, we have CaS. Now, in this case, Ca is going to be this one right here, or calcium. For our cation, which is Ca, because remember it's cation first, anion second, our Ca is just calcium. We just need to write calcium in here. And now we have S. Now S is a bit different than those other ones. So we've done fluorine becomes fluoride, we've done chlorine becomes chloride, we've done bromine becomes bromide. But S is a bit different. That one's sulfur. So sulfur I'll write it up here. Sulfur. We're going to cross off that ending, and sulfur becomes sulfide. So you can see that all of our anions are going to have that same ending, that IDE ending. And now that IDE ending will help us a little bit later on, because we'll know if we see something with an IDE ending, it's probably going to be one element as an ion. Now that'll come in handy in part 2 when we talk about something called a polyatomic ion, an ion with multiple atoms. But we won't get there yet. Let's talk about some more complicated examples just with our rules that we've gone over so far. Now in this case, I have 3 more examples, but you'll notice some of these have some subscripts. Now in the case of ionic compounds, we don't care about the subscripts. We don't care about the subscripts for naming. Now when we're going from name to the compound, so kind of doing the reverse of what we're doing, we will need to put those in. But for naming, we don't care about the subscripts for ionic compounds. Now, we'll go over some names of a different type of compound later on, and we will care about those subscripts. But for right now, we're going to not worry about them. Now in this case, we have Mg3P2. I'm going to cross out the rules we're ignoring again. Now Mg is right here in the periodic table. Mg is magnesium. All I need to do is write magnesium. Now P, that's going to be phosphorus. Now that's a tricky one. Phosphorus is going to become phosphide. I might have to write tiny to fit it in. There we go, phosphide. Then we have BaO. We're going to continue our pattern. We have our Ba here. Now Ba is barium. That's our cation. Remember that second column is going to be 2+, and that first column is going to be 1+, so we know those are our cations. And then that O is oxygen. Now we're getting pretty good probably at this point doing those root plus IDE. We know sulfur becomes sulfide, phosphorus becomes phosphide, oxygen becomes oxide. So this one is called barium oxide. Now we have one last one, and this one has Al, and Al is right here. Now we see right here, we sort of see the stair step where these are green right here. Now this is sort of that threshold for metals. So aluminum is a metal. It's still going to be a cation. It actually is a 3+ cation here. And so we name this cation first, so aluminum. And then we've actually done chlorine already. Chlorine becomes chloride. And I'm actually going to erase that and make sure it looks like there's a space, so there is a space between these words. Perfect. So we have done 6 names with our first rules of ionic compounds. So we're element name for the cation, and then the root plus IDE. These are if there is just single atom types. Now, in our next part, we'll go over those polyatomic ions. But until then, good luck studying, and try naming some ionic compounds you find on your own.